only in the left hand and those who can write only in right hand. There are ambivalent also. We can have vision on both the eyes. Some people can write on both the hands. So I want to test whether there is any association. Here we are not talking about relation. We are talking about, is there any association between the eyedness and handedness of the student? In such situations, you will be using chi-square test, non-parametric test. Because there you will have only frequencies. Number of students who can write in the left hand. Number of students who can write in the right hand. Only you have frequencies, not the real data, not the real score. So when you want to find such associations, we will be using chi-square test. So this non-parametric test sometimes referred to as distribution free test. It is not bothered about the distribution. Whereas parametric we have focused on distribution. So this doesn't depend upon the distribution. That's why it's known as distribution free test. When you assume the data in your population of interest do not have a normal distribution. This is the first condition. When you assume that your distribution doesn't comply with the condition of normality, we go for distribution free test. That is non-parametric test. That is compared to parametric test, which makes assumptions about the population parameter. For example, what are population parameters? Yesterday we discussed. Population parameters, which is indicated by Greek letters, mean, standard deviation and all. Mu, sigma, remember? Yes. So when the parameters which makes assumption about the population parameters such as mean, standard deviation, when the word non-parametric is used in the statistics, doesn't quite mean that you know nothing about the population. You know something about the population, but we know only the frequency. I am not bothered about the mean and standard deviation. When you go for parametric, it will bother about the mean and standard deviation. Next slide. This is the major difference between parametric and non-parametric. The first one is it requires parameters. What is parameter? What is statistic? Parameters are the numerical value that states about the population. Is it not? Statistics, the numerical quantity or value that describes about the sample. So to apply parametric test, we need parameters. What are the parameters? Mean, standard deviation and so on. Okay. To apply non-parametric, we do not require any parameters. We require only frequencies. Okay. Second one. Require certain assumptions about the population, whether the population is normal or not. To apply parametric, the population need to be normal, the first condition. If the first condition fails, you don't go for parametric. The very first condition, a very important condition to be satisfied to apply parametric test is the distribution need to be normal. Okay. For non-parametric, no assumptions required about the pattern of the population. I am not bothered about the pattern. Whether it's normal or non-normal, I am not bothered. I need not know anything about the distribution to apply, because I cannot come to a conclusion about the distribution. In such situation, I will take the help of non-parametric tests. Then these tests give precise result. Yes, because it takes into consideration the real original score. For example, your mean takes into consideration the original score. Is it not? So it takes into consideration the real original score. So parametric test gives very precise result, whereas non-parametric test will give less precise result. For example, when you are doing correlation using PS, product moment correlation, called PSS product moment correlation. So when you are doing correlation using that, every score of that distribution is taken into consideration. You will use the exact score. Is it not? Whereas when you are doing the same correlation for Spearman's rank difference, we don't take the real score. We only first will rank them. After that, we only bother about the ranks. Ranks are only taken into consideration. So when you do such, so Spearman's rank correlation gives less precise results when compared to PSS product moment correlation. That is why when we say when you are doing B.Ed, you can do correlation with help of rank difference. But when you come to M.Ed, you will do correlation only with reference to PSS product moment. For all your dissertation thesis work, you are expected to do only PSS product moment, not Spearman's rank difference. Do you get my point? So because PSS takes the real score into consideration, so it will give a very precise result. So what kind of test it is? Parametric. Whereas Spearman's rank only bothers about the rank. So what kind of test it is? Non-parametric. That's all. Understood? So it gives less precise result. Then these are stronger tools, more efficient. To test the hypothesis, you are mostly using the when it's parametric, it gives a very accurate result, strong result. Because using a strong tool, sophisticated tools are used. Whereas these are weaker tools because they are very less efficient. Next, computation takes more time. As we saw how much we are, the time invested for doing ANOVA t-test, it involves more time. Whereas it involves only few calculations only. When you do the problem, you will understand. It involves only very few calculations, the non-parametric test. It is not such a laborious calculation is not involved while working with non-parametric tests. Next, not useful in the data ranked or ranked. This is rated. Ranked or rated, ranked or rated. This is not useful for the data which is ranked or rated, whereas more useful for the data that can only rated or ranked. Because we are not ranking there, we are taking the real score there. Here we are taking the ranks. We are rating it. Okay? That's all. This is the main difference between parametric and non-parametric. So, what kind of data can be used? There are 4 kinds of scales. As I told you earlier, when you are using parametric test, the scale used to be either interval or ratio for parametric. Okay, the data should be collected using the scales of either interval scale or ratio scale. Mostly in social science research, what we are doing, we are collecting the data using interval scale. Mostly you are collecting data, psychological tools when you administer, you are collecting the data using interval scale. Okay, not ratio. Only physical sciences they will be collecting data using ratio scale. So for non-parametric, the data scales used to be either ordinal scale or nominal scale. Okay, you know what is ordinal, what is nominal, right? Yes. For internal ratio scale, use parametric test. This is basic condition. Next slide. Reasons to run non-parametric. Why should I go for non-parametric? One or more assumptions of parametric have been violated. I have given 4 conditions for parametric test. 1 or 2 conditions are not satisfied. Give away with the parametric. Go for non-parametric. Leave off the parametric. Because you get the point. I gave you 4 main conditions to be satisfied. Even 1 or 2 conditions violated, don't go for parametric. We have to go for non-parametric only. Next, sample size is too small to run a parametric test. So non-parametric test sample size can be small also. Then you have to large sample, maybe 5 or 6 students. You can do non-parametric. You cannot do parametric test over there. Next, data has outliers that cannot be removed. As I told you, when there are outliers, you cannot apply parametric test. But there are certain situations you are having outliers because your sample is such. I cannot give up. So, for example, you are working with special children, autistic children. Getting autistic children is very difficult. There the sample size will be very less. Their response will be outlier. It's the thing is I cannot give up because I cannot find another subject. Do you get my point? So there are situations where I cannot remove the outliers. Then I have to go for only non-parametric. Next, what to test for the median rather than the mean. Suppose your test is mostly depend upon the median. Then non-parametric is only used when you put this. The basic center tendency is mean. Then you use parametric test. So when you look at parametric test, everywhere the mean is reflected. In all the formulas you will find the mean. Do you follow? So when you have taking into consideration median as the basis for center tendency, we will adopt to non-parametric tests. These are the common number of tests. I am just quoting few. Common non-parametric tests included chi-square test, sign test, Wilcoxon sign rank test, Mann-Whitney U test, Kuskal-Wallis test, Friedman test, and so on. Okay, in this we are going to focus on 4 types of tests: chi-square, sign-square, Mann-Whitney, and DMRT. One more. Okay, DMRT is nothing but post-hoc, which we have talked about, which we are discussing yesterday after ANOVA. Remember? Yes. Next, when to use chi-square? The chi-square test is used when there is a relationship more than anything called the association. When there is any relationship between 2 or more nominal or ordinal variables expressed in classes or categories. Here also class, here also categories. Okay, they are expressed in terms of class. As I told you, I-ness, handedness. They are classes, left hand, right hand, left-handed, right-handed. Okay, you follow? So when the class, the data is divided in terms of classes or categories, we use chi-square test. Next, to compare the experimentally obtained results with those of the expected theory. There are certain theories say this is the result. When I want to compare the experimentally obtained result with the theoretical result, established fact, we go for chi-square test. And next, we call that as a goodness of fit. Goodness of fit. Chi-square test is otherwise known as test of goodness of fit. Whether the theory is fit for us. When you have collected data, whether my data goes with the theory. This is the association between the theory and what I collected. So goodness of fit. When we do not know anything about the nature of the distribution, as I told you earlier, but to apply T and F plus, the distribution need to be normal. But when you do not know anything about distribution, quietly take up non-parametric test. That is like chi-square test. Where the size of the given sample distribution is very small, we cannot use T and F test. Chi-square test is the only best condition in such situations. This is also given earlier for non-parametric test. Yes? Now I given a problem how to apply chi-square test. See, for example, there are 42 parents of school children who are asked to state whether they agreed, disagreed, or indifferent towards online learning. Online education is implemented nowadays. You are getting the opinion from your parents whether they agree with the online education or they don't agree or they don't want to say anything. They are indifferent towards it. Okay, what is the association between parents' opinion towards online education? You get my point? So I am getting 3 categories are given now. 3 categories: agreed, indifferent, and disagreed. So 80 parents agreed for online education, 8 indifferent, 16 disagreed. So totally 42 parents are there. So what is that? What is expected? We expect them to give equal opinion. I want everybody should be equal opinion on all the 3 categories. So 42 is the total number of participants. So how many categories are there? 3. 42 divided by 3. 14. I expect 14 in every cell. But I am not getting 14. So I am going to test the goodness of it. It's equal probability theory. Equal probability theory says equal in every cell. So 42 divided by 3 categories, 14. So it's not this one. 1 second. The formula to compute chi-square is sigma FO minus FP the whole square divided by FP. Where FO is the observed frequency, FP is the expected frequency. This is the formula. Sigma of F4 minus Fp the whole square divided by Fp. See, now we expect 14 everywhere. This is what expected. Total of 42 students, 42 parents are there. I want equal probability, I want equally it should apply everywhere. So 42 divided by 3, 14 in all the 3 cells. Do you get my point? So expected frequency is 14. Okay, now FO is observed. What is given in the problem? That is observed. When I conduct a research, I am getting only this result, 18, 8 and 16. What is expected is 14 in all the 3 classes, all the 3 categories. So FO minus FP, 18 minus 4, 8 minus 4, 18 minus 14, 4, 8 minus 14 minus 6. I think you follow all that. Okay, so FO minus FP, FO minus FP, FO minus FP. Up to 3 levels. Okay, I am getting 4, 6 and 2. Square it up. Find the square of it. So 16, 36 and 4. Divide F4 minus Fp the whole square by Fp. F4 minus Fp the whole square is 16 here. Fp is 14. 16 divided by 14. That is the formula says. Formula says sigma of F4 minus Fp the whole square by Fp. Is it not? So Fp minus F4 minus Fp is 16 by 14. 36 by 14, 4 by 14.
Why should I expect all should be 14 then?
Equal probability. We want all the 3, when they take up what is the null hypothesis? There is no significant association. So all the 3 should give the same opinion. That is what null hypothesis. We start with that, we land with what is what has happened. Okay, we say that whenever we start a research, we should have equal. Everybody should be equal on the platform. Then only I can compare. Do you get my point?
Yes.
Okay, suppose you are comparing with the research knowledge of boys and girls. First you equate them. Suppose there are certain students who have got higher research knowledge. You are introducing a research methodology course. Then afterwards you are saying these girls or these boys are enhanced as girls. No, because originally they possess higher knowledge.
Okay.
Do you get my point? If you are going to compare all MBA students. Don't compare MBA with PhD.
Okay.
Do you get the point? They should be equal on the same platform. Then only I should go for the research. So, equating here. Like what is expected, they are equal. We find all the parents should give equal number of opinions.
That we know that everywhere it is 14. Then why this again the formula is? We know that everywhere this 14 will be equal.
This is what we expected.
Yes.
We see what is really existing.
Okay. What is the difference we are seeing?
You will come to the result. And the result will tell you.
Okay.
Okay, whether your parents are giving really favorable opinion or not.
Okay.
To get whether the parents are for online education or not.
That we can see by the agree itself.
No, that's what scientifically we are saying.
Okay,
Maybe they are influenced by their friends' parents.
Okay.
Maybe they are influenced by their, my daughter's friend's mother.
How it will show here? Some other influence there. But how here it will show?
I am removing that through the studies.
Yes, thank you.
That's all. Okay. Somebody is influencing. I want to remove all that. The influence we have to get rid of. For that only we are going for studies. Otherwise, as you say, 18 people agree, so let us go for online education. No. Okay, there are certain influential factors always there in the social science researchers. Okay, because the individual being a social animal. You are influenced by the person sitting next to you. Okay, in some way or other. He will be influenced by you in some way or other. I want to get rid of all that. Do you get my point? Okay, yes. So applying that, you are getting 16 by 14 because it's sigma. The formula says sigma. So add up all that. I am getting 56 by 14, that is 4. So the chi-square value, the obtained chi-square value is 4 now. I have to table, standard table. To refer the standard table, we need degrees of freedom.
Yes.
Okay, df, to find df for this chi-square test, the formula is r minus 1 into c minus 1. R number of rows, c number of columns. Here there are 2 rows, F1, Fe. 2 minus 1. There are 3 columns. Indifferent, agreed, disagreed, indifferent. 3 minus 1. So 1 into 2, 2 it is. Now refer to the table. When I refer to the table, chi-square value for the degrees of freedom at 0.05 level. There are 2 levels as I told you, 0.05, 0.01. At 0.05 level it is 5.99. Okay, since this chi-square value is more, the obtained value is lesser than the table value now. Since the obtained value is lesser than the table value, what will you do? You will accept null hypothesis. So you will come to a conclusion. There is no
significance.
Association. So though we found association in the 18, you asked the question, no? I answered the question.
Actually, that is a human-made error. Can that be reduced by numbers?
Yes. By scientific you can reduce it. That is why statistics. Statistics come into play is not only because of that. Human errors can be eliminated very sophisticatedly, scientifically with the help of statistics.
When all the 18 answers are influenced.
Yes, not all the 18 answers. The questions, in the question items.
Can it be perfect? Can it be perfect that this formula says perfectly how much it is influenced?
Yes. Not the degree of influence, you have higher statistics, rigorous analysis. It will say removing the influence, is there any difference? Or they are giving what is the real picture available in the society.
Which point here is removing the influence?
This is what FO, FE. FO and FE, difference between FO and FE. That is removed. Observed and expected. That is removed. Okay? Yes. This is how you do chi-squared for simple one. Yes, next slide. You can have this type of table also. What is this? We have a contingency table. Classification. There we had only one classification. Now we have 2 years we have got classification. In the row wise also you have, in the column wise also you have classification. Okay. For example, the marital status is one variable and the type of response is another variable. So what is the this is the null hypothesis for the data given below. Married, unmarried. Yes or no? Okay. So number of response for yes is 70. Number of response for no, or the married individuals are successful in their research in pursuing their PhDs. Suppose for example I am giving. Or the married individuals are successful in doing PhD research after marriage. Do you get my point? So people are saying yes. 70 people are saying yes. And 23 are saying no. I am not successful. Similarly, unmarried says yes. Unmarried people are saying they are successful in doing research. 28 people. And 22 says, though I am unmarried, I am not successful. So this is what I am having. To find out is a significant association. So you get this is we got as contingency table. This is a contingency table of 2 by 2 type. 2 rows into 2 columns. Okay, you find the total. Only this one only be given. I am only finding this total. Okay, so 17 plus 23, 40, 28 plus 20, 50. Similarly, row wise, column wise, we identify. I have given A, B, C, D. Problem will not say that. We will, all the letters given, the letters are pointed out by us. So we have assigned the name A, B, C, D. The total is N. This way you and also will get, this way you also will get this. So this is A plus B, this is C plus D, A plus C into B plus D. Do you follow? This is a contingency table. Yes, the formula differs. The formula to apply chi-square test is here N into AD minus BC the whole square divided by A plus B into C plus D into A plus C into B plus D. This is the formula. There we set sigma of F4 minus FP the whole square by FP. Whereas here the formula differs because it is contingency table with A, B, C, D. Do you get the point? Now, for testing the two, so you apply and get the answer. Now I given the formula, you can apply and get the answer. I didn't work out the problem. Okay, next. Sign test. Next test is sign test. First chi-square test is over. Now we are passing on to sign test, now another non-parametric test. When can you use sign test? So sign test for 2 matched samples. For testing the 2 population distributions are identical, I want to test whether these 2 population distributions are identical. Then you see, try to use the sign test. And next, the sign is based on the signs. The main focus is signs, plus or minus. That's right. That's the name itself, sign test. Plus or minus of the difference between the observations of matched pairs without regard to the magnitude. How much different they are not bothered. Whether they are positive, is they differing or negative. That is only their botheration. Okay. And next, when the normality of assumption is not known, as I told earlier, this is non-parametric test. So normality is not known. I can take the help of sign test. The formula is Z equal to x minus np divided by square root of np into 1 minus p. P is probability of occurrence. P refers to probability of occurrence. N refers to sample size. Yes, go to the next slide. So this I also told you here, the same data distribution, you are not bothered. 2 samples are taken. Dependent samples should be paired samples or matched samples. That's what the sign test for matched samples. Yes, next slide. Next. I have given the formula. N is number of positive signs and rho T is total number of signs of difference. P is probability of positive signs. Okay, so we are only bothered about the sign of the number, not the real number. Okay, going further. Next. Null hypothesis. If 2 samples are identical or no significant difference between the 2 samples, this is what our null hypothesis. You are going to apply the formula. After applying, if Z value is less than 1.96 and 5% level, you will try to accept. Otherwise, you will reject. We are coming to a conclusion, they are differing. The 2 populations are differing. Going to the next one. I give a problem. There are the first set of 22 patients are measured before and after administering drug. They are going to administer drug. They are getting the pulse rate of the patient. 22 patients are there. Okay? Yes. Drug has no null hypothesis. Drug has no effect on the pulse rate. Whether they take a drug or not, their pulse rate are the same. That is what null hypothesis says. But we need to find whether drug is really effective or not. Yes. Go next one. Because both the samples are identical. Why only same 22 patients? Okay, they are only taking a drug. First, their pre-test is conducted, then drug is administered, then their post-test is conducted. Is there any difference in their pulse rate? This is our question. So, I have given the 22 items. See, now, this is before administration of the drug, this is after one. Is it not? So, before it is 72, after the drug, 74. The difference is positive. Similarly, this is also positive. This is also positive. Fourth one, fifth one. 73, but after drug it is 72. The sign is negative. So it goes like that. There are some situations here, 72, no change. Even after administering drug, no change. The patient is the same. So I have had like that. Understood?
This frequently taken pulse rate.
No, only 2. First pulse rate.
No, here different numbers are there, no?
Yeah, 22 patients.
22 patients for every.
The first patient, second patient, third patient, and so on.
Okay.
My sample size is 22.
Okay.
Okay? So the change of signs is given. Next is X is number of positive signs. How many positive signs are there?
15.
15. Because 2 no change, 5 negative signs, positive signs is 15. So N equals X is 15. Now N is number of signs of difference. 2 no change, so 22 as a positive negative is changing. And then so P is probability of getting signs. Either this will change or it will not change. So probability is 1 by 2. The drug should have effect on the pulse rate or it should not have the effect. So 1 by 2 is the probability. Either this or that. The tossing
There are positive many, no?
Huh?
Positive only many, no? Then how it is 1 by 2?
No. Only 2 options. Either drug should be effective or drug should not be effective. Only 2 options.
Okay.
So 1 by 2. Tossing a coin. Either head or
2
tail.
is usual.
If you conduct 10 times, what is the probability of tossing a coin?
1 by 2.
The same. Okay, 1 by 2. So applying the formula. I have given the formula. In the previous page I have given the root of NP into 1 minus P. I am applying the formula here. So you are getting the answer to be 2.236 after application of the formula. Which is greater than 1.96 at 5% level. Then what does it mean? That the drug has got effect in changing the pulse rate of the individual. As a result of the drug, the pulse rate is increasing. Because most of the things are positive. Yes, that's what. Drug has got the effect. This is why. Here we are only bothered over the signs, not original score. That is why it is not parametric.
Again we are doing that 5% significance only.
Yeah, because 1% is less. So that's why we went for 5%. Always we will check for 1%. If 1% is not satisfying, we will go for 5%. Even 5% is not satisfying, we complete concentration, no difference. Not significant.
If the null hypothesis is not accepted, what should we do? Again the test will be conducted.
No, this is not. This is,
Here it is accepted.
no, this is not accepted here.
Okay, 5% is okay, no?
5% okay, that's why we are accepting.
Yeah, I'm saying if it is not accepted.
We accept the null hypothesis, we say there is no difference. Suppose your value happens to be here, your value happens to be 1.43.
Okay.
Your value is 1.43, but the table value is 1.96. You accept null hypothesis.
Yes.
I will come to your conclusion, drug has got no effect.
Okay.
That's all.
Here there is an effect.
Here there is effect.
Then the null hypothesis is rejected.
Rejected.
So when it is rejected, which means there is difference in the drug.
Yeah, so the drug can be administered to any number of population.
Okay.
Because it's got this effect. The research proved that it has got the effect. So it can be administered to all the patients.
Yes.
Do you get the point?
Yes.
Yes. Next one. Mann-Whitney U-test. Third test. Mann-Whitney U-test. This is another non-parametric test. Mann-Whitney U-test is non-parametric alternative test to the independent sample t-test. Remember we did independent sample t-test yesterday. T equal to m1 difference m2 divided by square root of sigma and square by n1 plus sigma 2 square by n2. So this is an alternative for that, as we are asking for an alternative medicine in the shops. This I will give you an alternative drug. Similar to that, this alternative non-parametric test for the independent sample t-test. So it is used to compare two sample means that come from the same population and used to test whether the two sample means are equal or not. The test is more efficient than the sign test. Do you get the point? Yes. Now, Mann-Whitney U-test is particularly useful when we are assessing the difference between two independent groups with low number of individuals in each group, usually less than 30. When I told you when the sample size is very small, we go non-parametric. When sample size is big, we go for parametric. Since sample size is very small, I am going instead of student t-test, I am going in for Mann-Whitney U-test. The samples, even when you look at the null hypothesis, it will be same. There will be no significant difference between two sample means. It's null hypothesis there, here also. Why I am going for this? Because sample size is very less. I cannot apply t-test. Do you get the point? Yes. Next one. The two samples are not significantly different. There also we write the same. For t-test also, the sample means are not significantly, the two sample means are not significantly different. So here also we are saying the same. The two samples are not significantly different. Ranks are assigned to every score by combining the scores of both the samples from lowest to the highest. I will come to the problem. We are setting two sets of scores. You will keep on ranking all the scores irrespective where they appear. Either the first column or second column. For example, in the correlation coefficient, you will have one set of scores, you have another set of scores, X and Y. You will give rank only within X. And you will give differently separate ranks for Y. Here it is not so. You will give the whole data, you will start giving the rank, irrespective where it appears, either X or Y. That's what I am trying to say here. The formula applied here is U equal to N1 N2 into N1 of N1 plus N2 divided by 2 minus this. This is the formula. Sit up. Yes, go to the next one. Next slide. What is the explanation for U1, U2 given? This you have to take this formula only, no issues. Yes, go to the one. Next one. I have given a test is administered random sample of 10 students. Because it is only 10, I cannot use t-test. Sample size is very small. I cannot use t-test. Two samples are there. University A, University B. In the first university 10 samples, second university there are 11 students. Now test whether the performance of two groups of students is the same. This is
for the t-test minimum sample is
less than 30, at least 25, 27, at least more than 15 should be available.
15.
1.5.
1.5. Here is only 10.
10 or 11. Performance of two groups of students is same. That is the hypothesis.
Yes.
Okay, let's go next slide. University A, University B. Data is given. I am starting giving the rank from lowest to the highest. Lowest to the highest. So the University A, it is 1. Okay. Where does 2 appear? The next highest?
56.
56. Next one? Here.
That's it, sir.
So what I am trying to say, you have to give the ranks combining all the data.
Okay.
Not separately here, separately there.
Understood.
Okay. Whatever given, yellow is given by us for the calculation. Okay. So like that you are doing it, so it will land with 21. The last rank will be 21, is it not?
Yes.
10 here, 11 there. So altogether last rank will be 21. This is how you are giving the rank. You see both the data, start giving the ranks from lowest to the highest. Irrespective of whether they appear University A student or University B student. That is not our bothering.
If 2 marks are same, we skip one rank and go to the next one.
No. You have to give the average of the next two ranks. Suppose two Spearman's rank correlation.
Yes.
This question is a very right question. There are 2 students getting the same score. One in University A, one in University B. Suppose it happened to be 5th rank and 6th rank.
Yes.
In your schools, what you say, you give 5th rank for both the fellows, you skip the 6th rank.
rank.
It is not so. In statistics, you cannot do that. You cannot skip anyone. So give 5 and 6 average of that. 5.5, 5.5. This is what you do for Spearman's rank correlation.
Yes.
The same thing. Statistics very precise. You cannot skip anyone. You cannot skip anything. Okay? That's all. So you give, please. You assign the ranks, take the total. Total first rank or total second group of ranks or 2. Yes, next one, you apply it to the formula. R1, R2, N1 is 10. First students, 10 students were in the first school university. 11 students in the second university. So apply in the formula. You get U. You get E of U. Just real substitution multiplying and dividing, that's all. Okay. Substitute everywhere you are getting. Finally you are getting Z as 0.21. Okay. Z is the mathematical U test. Z is 0.21. Is it less than 1.96 or not?
Yes.
Yes. Then what will you do?
Then we reject the
value is less than 1.96. When the value is less than 1.96, you accept
the
null hypothesis. The 2 means are same. The 2 sample means are same.
Here the Z is the sample.
Yeah, Z.
The Z is the sample.
U statistic. Mathematical U statistic.
So both the universities marks are same. Significant.
Yeah, the sample means are significantly the same. Understood? This is how you will do mathematical U test. Understood? Any doubt you ask me? Am I very fast? Yes. Now against the computer performance of 2 groups of students is same. We started with null hypothesis. We landed with the same null hypothesis because the value happened to be less than 1.96. Okay?
Need such sums, ma'am. If you have any sums,
Okay.
you can give to them. We need practice for all this.
Okay. I'll send it.
Otherwise, we'll forget.
I will send it to me. Yes, next one. So third is over. Man-made U test over. First one is chi-square test. Second one is sign test. Third one, sign test, it takes into consider only sign of the number, not magnitude. Here it takes into consider ranks of the numbers. Only ranks. But combining both the groups. Remember. Combining both the groups.
Can we call this as a rank test?
No, they are named as man-made U test. Okay.
What is the U in this? U is the
Man-made T, he has named as U. He has named it. Students T, why this T? Their statistician is named as T. Like that. The man-made T is named as a U.
U refers for nothing.
No, nothing. Indication. Sigma, what does it refer? Nothing.
Two types of sigma, like this one.
Summation
and
of
this
sigma.
one. Summation sigma is that E reverse.
Yeah. The sigma standard deviation. They gave the notation. You cannot question that. The standard P is that is.
Just for remembering, I'm asking.
Yeah. You no, no indication for that.
Thank you.
Yes, next one. Last one, DMRT. Duncan multiple range test. This is not a post-op test. Yesterday I told you when you are doing ANOVA, F test, when the F value happens to be significant, what will you do? When the obtained F value is significant, what will you do? You will accept or reject. The value what you are getting is greater than the table value. Significant is greater.
Yes.
Is greater than the table value. What will you do?
Accept the.
Reject null hypothesis. When obtained value, remember always, this is the base rule. When the obtained value is greater than the table value, you reject. When the obtained value is less than the table value, accept. Lesser is accept, greater is reject.
Our value, that obtained value is lesser is to accept.
Accept. Obtained value is greater is reject.
Then we fall. We will not come.
Yeah, you should not go beyond that. That's what. Okay, reject. So F value is significant. Then I said you have to go for testing every pair. Remember, when there are 5 groups, 10 pairs we have to compare. Yesterday I told you. When there are 3 groups, you have to compare 3 pairs. So instead of that, I said you can go for post-hoc test. Yesterday we did all that. Post-hoc test, where we took the combined standard deviation, square root of the error variance, sigma d. Then you took the table value, multiplied by sigma d, and you got one t value. You compared every mean difference with that, which is differing or not differing. That is only Duncan multiple range test. There are number of post-hoc tests. When I am doing SPSS, when you go for post-hoc, you find number of columns. Duncan, Sheffy, Taki, and so on. Okay, Duncan, this is DMR is Duncan's test. How does he apply that? Okay, we are going to data. But when you go for SPSS, nothing necessary. Just go to the post-hoc, box will be given, check box. Put a tick, Duncan, it will give the report. That's all. But how does that software is derived? How does they arrive at the values given here? I am explaining that process here. Okay? Yes, next one. This is ANOVA test. Suppose this is the output of the ANOVA test. Data is given. These are the 3 groups data. Here, this is the ANOVA table. Sum of squares, TF means sum of squares. Okay, this is the original data. These are the means for the data. This is the ANOVA table. Do you get my point? After working, I am getting this table, ANOVA table, F table. Now, how will you get F now? Between divided by, within will be F value. Always, F plus F value is between mean square divided by within mean square. Remember? So, 542 divided by 2 divided by 8.78 will give you the F value. Now, you are finding out the rank treatments from the highest to lowest mean. What are the? These are the 3 means. You rank the highest to lowest. This is first one. Second one, third one. I am ranking. The first step is I am ranking the means. To apply DMRT, please listen carefully. To apply DMRT, you rank the means from highest to the lowest. We are ranking. Yes, next slide. The next step is now we are going to compare the highest mean with the lowest mean. The highest is 39.3, lowest is 11.3, in between we had 20 point something we had in between. First I am comparing, at a time I tell you can compare only 2 means at a time. Is it not? Even if you want to compare 3 students who is higher, how will you compare? First you compare A with B, you take the bigger one. Then you compare the B with C. Then you say this fellow is big, height. Do you follow? Who is tall? If you have to find out who is tall, you compare A with B, you take out the tall person, then compare the tall person with the C, then you find out who is the tallest. This is a process. This is how mind also works.
That's why the competitions also will be conducted.
Yeah, the same way here. I am taking two at a time. I am comparing the highest with the lowest. 39.3 with 11 points. The difference is 28. Now step 2. Look for that. Look at the few value table for with 3 treatments and 6 degrees of freedom. There is a few value table is there. Why is 6 degrees of freedom? Because there are 2 treatments, 2 rows and 3 columns. So 2 into 3, 6. Okay. So a Q table is you can point out the last I have given the Q table.
Q table.
In PPT. I have my PPT.
Go to the last slide of the PPT, please.
Right click, last slide. This one. This is a Q table. So the 6 treatment number 6. What is the value?
3.46.
Okay. This is a Q table. Yes.
6 and you are calculating with the 2.
Yeah.
The row, it is 2.
Yes. Okay. Yes. Go to the previous slide. The one which we were working out. 3.46. Okay. 6 degrees of freedom for the error term. This Q is 3.46. Now step 7. Multiply step 4 by the new Q value. So what is the step 4 previous page? The difference we found now? Earlier. Please previous. What is the step 4?
The root 5.86 is equal to 2.4.
Here only. So Q value we found 4.34. Now step 3, find sigma d squared. Sigma d squared is 2 into residual mean square divided by n. Residual mean square is error square. F table BSS. In the F table you find BSS, no? That is error component. Go to the previous. This one. This is residual. Always error component. Our purpose is to remove the error. Another was to remove the error. Which is residual? Error. How will you filter? The sediment that's falling in the below the pipette only you filter it now.
Yes.
See, you are preparing filter coffee. Which will you remove? The powder dust. Similarly here. Residual is nothing but the one is deposited. Because it is an error. It is not going to help us. Only the decantation is going to help us, not the powder. Same way. That is why it is statistics. You are removing the errors only statistics. Statistics you are removing the errors. Okay. So you take the square root of it. Next slide. I am trying to take no previous. Step 4. Here. 2 into residual mean square. 2 into 8.78 divided by, this is our formula. Okay, I am getting one value. Step 4, compute sigma d. If we want to found the sigma d squared, we need sigma d, take the square root.
Yes.
So I am getting 2.42. Step, multiply sigma d by q value. Q value just now we found from the table. Multiply that, you are getting is 10.5. Now, the difference between the highest and lowest mean is, you are getting it is 10.5. What is the difference? 28. If your test want to be significant, it should be more than this value. This is not more?
Yes,
this is more.
It is more.
So you are rejecting the null hypothesis. And coming to your calculation, these two groups are differing. Group 1 and 3 are differing. The highest and lowest mean values are significantly differing. By looking at them, they are differing. You know, 39 is very big number. 11 is a very small number. Still, why you go for all these steps?
How much the significance is?
Significance, removing the errors. Again saying, removing the errors. That is statistics. Statistics play its role only to remove all our human errors. Apart from that, they want to see really there is difference or not. Understood? So they are different. Similarly, you go for another combination also. We compared 1 and 3 now. You can go for 2 and 3 also. There is a difference with the highest low mean. So the highest mean is significantly different from that of the lowest mean. Next, I am comparing similarly. Second with the same formula. So you are coming to know, now the difference is 8.3 now. But the difference, real difference is 9.4. Is it less or more?
More. It is 8.7. But here it is less.
This is 9.4. What is that? Then what will you say? What will you say?
So then the obtained value is 8.37. So accept it.
Like that you go, proceed. Okay? This is the Mann-Whitney DMRT. Sorry. Duncan multiple range test. Okay, next slide. This is the table. Q table value.
So such tables only removing the errors.
Such tables help us to see whether our values are different after removing the errors. Okay? Okay?
Yes. So
So
how these
Duncan,
such tables were made?
the some statisticians, their names are existing. We are not Fisher. We are not students. Their names are existing because they evolved these statistics. They are like Einstein. They are like Piaget. Okay? We are not Piaget. You are funny and I am funny and I am Piaget. Similarly that. They are not eminent person who evolved these tables. Okay? They are all fundamental researches. There are three kinds of research. Fundamental research, applied research, actual research. They are fundamental research who have evolved theories. Time and again tested and found to be true always. In any condition they are true. They are fundamental research. They are not only applied researchers. They are trying to apply their theory and see for the population whether that the theory suits for this population or not. Okay? Yes. So with this, my sessions comes to an end.
Have any doubt you can ask.
Yes. In any four sessions.
Adyataneva, Hastaneva, Kutrapi.
Yes. Previous slide. What is your doubt? You have to apply the formula. See, N1 means size of the first sample. First sample is 10. N2 is size of the second sample. Second sample size is 11. How previous slide? Previous slide? Next one. No.
Yes.
Here. How many students are there?
10 students are there.
N1 is 10. How many students are in group B? In university B? 11 students. So N2 is 11. Okay, go to the next slide. So N1 is 10, N2 is 11. R1 is ranking the first set of students in the university A. And some of the ranks in the second set of students in university B. R1, R2. Okay, you are applying the formula N1, N2 plus N1 into N1 plus 1 divided by 2. N1, N2 means N1 multiplied by N2. When I put in mathematics, when I put two letters next to that, it means multiplication. A, B means A into B. That is the mathematics works. You must be knowing that. Okay. So when I say N1, N2, what does it mean?
N1 into N2.
N1 into N2. Understood? That's why N1, N2 is N1 into N2 plus N1 plus N2 by 2 minus R1. So I am applying that to the formula. When you apply, I get this value. That is N is 10 into 11 plus 10 into 11 divided by 2 minus R1 minus 1. Work it out and see. You will get that value. Understood? Okay, what it? You want to work it out now. You will know. Okay. Next is E of U. E of U formula is N1 into N2 divided by 2 divided by square root of N1 N2 into N1 plus N2 plus 1 divided by 12. So I multiply, I am getting the value as 14, but just mere application only, multiplication and division. Is you want EU to apply that in Z formula. Z formula is CEU. You are applying EU here. In order to get EU, you have to work it out. Similarly, see, look, you do is standard deviation. You will find standard deviation mean to apply it in ANOVA or to apply it in t-test. Similarly, you are calculating U and you are calculating E of U to apply it in the formula for Mann-Whitney U test. That is that statistics is known as Mann-Whitney U test. We get the point now? Yes, you are applying and getting that. Not only multiplying and dividing, but you have got certain formulas to be applied to get every factor of that formula.
फार्मुला मध्ये EU इति अस्ति तद् आवश्यकं चेत् आदौ E किं U किम् इति आर्तव्यं तदनन्तरं फार्मुला मध्ये तत् स्थापनीयम्
It's a two sample independent sample T test where the sample size is very small. When independent sample T test will be applied when the sample size is large. When you have fewer number of samples like 10 or 9, you cannot go for independent sample T test. In such situations, you will go for man-Whitney U test, which is a non-parametric test. Okay? Yes. Any other doubt? If you have any question, you can raise it. And all the posts, anywhere you can ask me. No issues.
इतोपि संशयः अस्ति चेत् पृच्छन्तु
Suppose somebody that sample size is very less, below 50 or below 10. Suppose his color goes to that for a test. Anything is wrong with that test?
Yes, you cannot apply, sir. You cannot apply.
Cannot apply.
Yeah, you cannot apply because it will not fall within normal distribution. To apply t-test, the data should fall within normal distribution.
And what should be that number?
At least more than 20, like that. To apply small sample t-test. What is recommended is more than 30.
More than 30. But there is no specific rules there.
No. But then when doing research, we say 10% of the population should be your sample size. 10%. But that is depending upon the population. Suppose you are going to work with the higher secondary students. All over India, so many lakhs are there. I cannot go for 10% of the population. So in such situations, they will relax. They can say 2% or 1%. Suppose you are working with handicapped children. Then I can go for 10% of population. Depending upon the problem. Handicapped children in the city of, maybe in the Chittoor district. You are taking handicapped children in the Chittoor district. That population may be 240, something like that. Then 10%, 24 is enough. That's what they say.
Any more doubts? धन्यवाद
भागर्था विवशं तिक्तो भागर्था प्रतिपत्तये जगतः पितरौ वन्दे पार्वती परमेश्वरम्. Good morning, all of you. First of all, I would like to thank each and everyone for rendering me this opportunity to say a few words on this workshop and Madam Dr. Kalayar Arasi Madam. I would like to thank for the wonderful session for the parametric and non-parametric test and the different way of statistical treatment. And I would like to thank Professor R. Chandrasekhar sir and Professor P. Venkata Rao sir and also Professor Tirupati sir and other professors of these universities, and thankful to all the research scholars, all the assistant professors, associate professors and professors in different universities apart from the India, and thanks to MA students for the concentration about the research methodology and statistical treatment about the parametric and non-parametric tests. Thanks to all.